I apologize for the late posting of this recitation session video. The keyboard was not working in W210 yesterday, so I have to record this in my office a little bit later. So we are in week 5, and we have already learned several pretty intricate reporting tactics and techniques to use in dplyr, which is the package we're using from the Tidyverse. The data set we are using this week is real data, and it shows global baby food sales. I'm going to just show you that data briefly. So if we import it this way, it'll give us this view of the data, and you can see there are multiple countries from multiple continents and regions showing 10 years of data of the total baby food sales. I believe this is in like the 100,000s or something. And so we can see the United States here and then Canada, and you notice we have both continent and region. So we have North America, South America, Central America, and the Caribbean, and then we move on to Asia, and we have multiple regions and continents. So we have multiple levels of aggregation you're going to be doing in the assignment this week. But we're not going to be actually using this data in the recitation session. So we're going to be using our field experiment data, which we looked at last week, which has data from a company that sells mattresses online nationwide. And we have 3 weeks worth of data broken down into daily sales and advertising data. Now, I want to address a couple comments I've received in the feedback. Thank you for those of you who are filling out that feedback. One of the comments was they wished that the recitation session aligned with the assignment a little bit more. And I want to let you know why I can't do that quite as much as you'd like. So the point of the recitation session video is to help you with the assignment on 2 dimensions. I understand that from what you learned in the lecture slides to actually doing it on the assignment is kind of a big jump, so this is sort of a stepping stone, kind of fill in the gap here. But the way I want to fill in that gap is on 2 dimensions. Number 1 is it is hard sometimes to get the instruction of create a report that does this and understand what you're trying to do. So what I'm trying to do with a recitation session is you see the phrase, here's what I want, and then trying to help you fill in the gap of what are we actually trying to create and how do we do that. So as far as just clearing up the semantics of what is this report asking for, that's the 1 dimension that the recitation session is meant to help you on. The second one is to just give you more practice and make you better at these commands and understanding what they do and how to go about figuring it out. Right? You don't always have to understand exactly what the report will do from the start to finish before you get started. You can take some stepping stones, do a few commands, see what it does, backtrack, whatever you have to do. There's another dimension on which this recitation session could be helpful that I don't want it to be helpful, and that is I don't want it to be just take the code from the recitation session video and copy and paste it into your assignment and it'll work. Obviously that wouldn't be helpful, that wouldn't help you learn it, that would just help you get the assignment done without having you learn anything new. And so that's the reason I don't make it aligned perfectly, the recitation session, with the assignment. Otherwise, you could just blindly copy code without actually learning to do anything. So, but I do try to make it aligned enough that you can learn it and make it easier to do the assignment. So, I'm actually going to do this first step for you. This is something we did in the last assignment on the field experiment data. I'm shortening and selecting a subset of the variables. So if we take a look at this FEXP2 data, the field experiment data, we still have 4,410 rows, so we have 210 regions across 21 days from November 4th, I believe, up to November 24th. And all I have is the date, the DMA condition. We have the Google prospecting, Google retargeting, Facebook prospecting, Facebook retargeting, ad spend amount. So that's the amount spent on display advertising in each region on each day. We have the amount of mattress sales and revenue that happened on the particular day in that region, the population of that region, and then the week. It starts in week 58 just because I've given you a subset of the data. There was more than a year's worth of data before this. So weeks 58, 59, and 60. Okay, so question 2 asks us about DMA condition. So I told you this comes from a field experiment. If you know anything about experiments, we know that we have a treatment condition and a control condition. This was a little more complicated experiment. We noticed we had 19 conditions. So we had a lot of different conditions, a lot going on here. So it says use the count verb to learn which regions were assigned to each condition in the field experiment. And then it gives you what it's supposed to look like. So if you notice, we have DMA condition. There are at least 10 regions assigned to DMA condition 1. And then there's 21 observations, 21 days. So that's a pretty simple report. And maybe you forget how the count variable works. So let's just get started and see what we can figure out. So we start with our data, we pipe that into, all right, let's just try a count verb and see what happens. I think instinct would be, all right, let's use DMA condition, and let's count that and see what it does. This is not going to be the right answer, but hey, we know we can at least do this and see where we're at. So we have 210 instances of DMA condition 1, 231, clearly not what we want. We do have our DMA condition variable like we just saw in the image, but we don't have the actual regions. So that's not what we're going to do. Let's try DMA name instead. See what that gets us. All right, that gets us all of our DMA names. So that's the 210 rows we want. It gives us the number, the 21 instances from the 21 days, and that's great, but we're missing the DMA condition. So let me just show you a little trick. Group by can be helpful just simply to get another variable listed in the output data set. So if we group by DMA condition and then pipe that into here, now we get our DMA condition. Notice when we did the group by, that didn't expand the number of rows. We still have every region has one observation in this report. Aggregating the 21 days, but now we have DMA condition in there. So by using this group by condition, we're able to see the label, the DMA condition each DMA was assigned to. So that's just a little trick. Another thing on the assignment, I actually had to change the instruction. On the assignment, the regions have, in each country, I'm asking you to do a report. This particular number, I think number 2 on the assignment, asks you to just use the count variable so you can see how many countries are in each region. And so you're going to use a count, but if you use a count and then you don't, it's basically going to count 10 observations of each country. But what you're actually wanting to do is count the regions, which means you're going to count how many observations in each region, which is going to give you the number of countries. But that's going to be multiplied by 10 because every country is in there 10 times. And so there's a couple ways around that. What I instructed you in the instructions on the assignment that I added was to just filter and just get one instance of each country so that the counts actually align with the number of countries in each region. Hopefully that makes some sense, but if not, then maybe the instruction on the assignment will clue you into that. Okay, number 3, create a report of the total advertising expenditures in each DMA condition and week, along with the population in each DMA condition. So we're going to have to do something kind of tricky that we did last week, but let's get started on what is a little easier. So we know we're going to start with FEXP2, pipe that into, oops, sorry, I didn't mean to do that. Okay, that's our data. That's not what we want to do. So we're going to pipe that into, okay, we want total advertising expenses. Okay, so totals mean we're going to add some stuff up, right? Which means we're going to use a summarize statement. And the total ad expenses are going to be, let's just call it tot ad. And that is going to be a sum of our advertising variables, but we have 4 different advertising variables. We're just focused on the 4 display advertising channels. So it's going to be GP and GR and FP and FR. Okay, when we do that, GP, remember, is a column, 4,402 observations long, so is GR. So if we add those two together, it's going to add all of those up. We're going to have one column of all of the ad expenses in a given region on a given day. And then if we do the sum, it's going to add all the column itself up, and we'll get the single number we want. So this is just going to give us one number, the total ad expenses in the entire data frame. Across all of this, we spent $103,000 on these display ads. So we want it in each DMA condition and in each week. So that's actually, we're going to precede this with a group by statement. We are going to group by DMA condition as well as week. And when we do that, every combination of DMA condition and week is going to get a different sum here. So if we take a look at that, now we have 60 observations. We have 20 conditions. I told you it was 19, but there is this, let me show you, there's something, that's way at the end. There's this outlier condition that wasn't actually manipulated in the experiment. So there's 20 actual labeled conditions. And each one was there for, of course, 3 weeks. So we have what we want. We have the ad expenditures in condition 1 on week 58, or which is the first week, the second week, and then the third week, and then on to week 10 instead of week 2, because this is a character variable. At least it's coded as a character variable. So 10 is earlier in the alphabetical numerical alphabet than a 2 is. So all right, one thing we're missing, though, is that we also want the population. That was a little trick we did last time, and that is, okay, if we want the population, we have multiple observations of the population, and we don't want, we don't want to add that up. If we did the sum of population, that would vastly exaggerate the actual population, because the population is just what it is. It's not an addition of the 21 observations of population. We don't want that added up. But there is something tricky about this. Last week, the way we got around that was we took the mean of population, right? And so if we do that, okay, so we get the mean, but notice here, for example, we have 407,000.5 people. Our population variable, remember, is, every region has a population, and if you take the mean across the population, or across a region, it'll just give you the actual population of that region. But DMA condition is not, the same as the DMA name, because the DMA condition contains 10 or 11 regions. So we want to add up the population of those 10 or 11 regions, but we don't want to add it up 21 times. So we have to add it up, but then we also need to make sure we're not adding it up 21 times and having 21 times the actual amount. So we have a few ways around it. I'll just show you one way. If we add it up, we're going to have every region added up, but then added up 21 times. So if we take that sum and then divide it by 21, that will give us the actual population added across that entire DMA condition, across the 10 regions in that condition. So the population, so we know we don't have decimals, so that's a good sign. We have 1,474,500. So we don't actually know, is that reasonable? Is that the actual number of people in any given condition? I guess that's, 1 million. That actually seems a little off to me, because if we... So because we don't actually understand what is the total population here, what I'm going to do is let's get some more context. What is the total population in the entire data set, so we know if we've actually got the right numbers here? So what I'm going to do is filter, and I'm going to say date equals, I believe it goes 2019-11-04. So we do that, we have only the 210 observations, and if I want what is the total population in the entire country, at least represented in this data, then I will just do a summarize statement and add up the entire population. So I say, I'll just do sum of population, and I won't label it. So in the entire data, we have 110 million people. Divided by these 20 conditions, we would expect about 5 million per DMA condition, right? 5 times 20 should give us about 100 million, right? So we expect about 5 million, and if we do this division by 21, we are getting much less than 5 million. So I've done that wrong. Take a second, see if you can figure out where my error was here. In this group by, we've grouped by DMA condition and week. And then here, I've divided population by 21, assuming we have 21 observations of each DMA condition. So we want to add up all of the population and divide by 21, gives us the average within each population. But we're grouping by DMA condition and week, which means this number needs to be divided by 7, I believe, because we have 7 observations of each region in each week. So if we do that, Now we're in the range that seems a little more reasonable. 4 million in that DMA condition, 5 million in that condition. We had a 8 million condition there because one of these conditions has New York. So we have, I know, at least 7 million people in that one. So maybe that's condition 8. I'm not 100% sure. So this seems a little more reasonable. Okay, so that was kind of a long way to go about at least illustrating, hey, you can make mistakes and still figure things out just by, kind of looking through them and getting a little more context by doing an additional report. You have enough skill with this now, you can quickly do a filter and a summarize to get you some data that you want. Okay, so notice now we see in this DMA condition 1, total ad expenditures kind of dropped a lot in week 3. They also dropped in week 3 for condition 10 as well as condition 11. So you can see something happened in week 3. But you notice in condition 12 they didn't drop nearly as much. They also didn't drop nearly as much in condition 13. So that is the actual experiment, and I'll give you some details on that in week 12. All right, now it asks us to plot the weekly advertising expenditures by condition. Okay, so if we want it by condition, we want the weekly advertising expenditures. We only have 3 weeks, but we want to see it over time, what's happening over time. That's going to be a line plot. Anytime you're doing a plot over time, you typically want to use a line plot. So, all right, let's get started. We say ggplot, and then first thing is our data. Where is our data? It doesn't actually exist, right? It's this report, which we haven't saved anywhere. So instead of doing that, what I'm going to do is copy this report here, and now this is our data, and now let's pipe that into our ggplot statement. Okay, I'm going to get rid of this first one. Okay, so now since we've piped in our data, we don't need a data statement. We're going to jump straight into our aesthetic statement. X is going to be week. Remember, this is over time, so X will be our time. Y is going to be our total ad expenditures, which is labeled tot ad. And then since we want the weekly advertising expenditures by condition, we need to give color is usually our default, by condition, or dividing up our plot into different groups or factors. We want to color equals DMA condition. Okay, and then all we have to do is add our geom_line. Okay, when we do that, we see a plot where we have the labels for each condition, but nothing is plotted here. And actually, I will confess, I had no idea what was going on. I had to Google, why isn't this plot working? So on your assignment, it asks you to do this line plot with, of course, different data because we have a different data set for your assignment. But this will not be a problem. This will not pop up. I've done it on your assignment. It should work just fine. In this case, I think because there's so few data points and time-wise, you actually have to add group equals DMA condition. So it knows, all right, what am I plotting? And I don't know why it needs that, but how am I grouping the data? And so if you add group equals DMA condition, now it gives you the plot by that. So again, this will not happen on your assignment. This was something I didn't understand why it was happening this way. I had to Google it and find out. Okay, now the next question asks us, which condition had the largest decline in advertising in the 3rd week? So you can see here's the 3rd week, week 60, and you can see this condition here drops way down, right? And it's pretty clear, I believe, that this is the biggest drop. We have a big drop here, but that's not as large as the drop that happened right here. And so we need to look along here and see, can we match that color up? I think with 20 different conditions, it's going to be difficult to match that up. So how do we find which condition this was right here? We'll take a look at the actual raw data. It starts at something under 2,000, then a little over 1,000, and it drops to well under 500. There's only one other condition where the actual tot ad value goes under 500. So if we actually look at our data, we can either use a filter statement to find it, or we can just look at the original data. It's only 60 data points here. So we notice in DMA condition 1, it drops on the week 3, week 60, it's at 132.06, which seems pretty clearly that's this data point here. So that would be condition 1. Okay, here's some additional code that I've given to you, and that is to create this FEXP week. I wanted to create some data that aligns a little bit better with the assignment. So the next reports align a little bit better with your assignment to help you out a little bit more. Again, I'm not trying to make the assignment difficult, but I'm trying to find the right balance of the alignment. I don't want you to be able to just copy the code, but I am trying to make the data a little bit more similar so you can understand how to port sort of your understanding of these analyses with your assignment analyses. So we have 630 rows, that's 210 regions, 3 weeks. Okay, so we have weekly data from every region, and we have the advertising amounts, the web sales, and the population. Okay, pretty clear there. All right, so we're going to create a report called High A DMA. So this is high advertising by DMA. On your assignment, it's high sales country, and that's the abbreviation. That's what it's for, not his country. It's high sales country, so high advertising DMA. This is going to show the region in each DMA and week with the highest GP spending. So we're looking specifically at Google prospecting, and we want the region within each DMA condition that had the highest GPA. So we've got DMA condition. Remember, there's 20 of those, and then there's 3 weeks. So this should have 60 observations, and in every observation we want, okay, if within DMA condition and that week 58, that first week, which region within DMA condition had the highest Google prospecting spending? All right, what about in week 2 or week 59? Which DMA region or which DMA name within DMA condition had the highest GP spending? So we're starting with FEXP week, and we want the highest, which is going to be using a slice max, right? So let's start with slice max, and we want the highest GP, and we just want the single highest one, so we have n equals 1. All right, well, clearly, if we do that, that's just going to give us one observation, and that was in New York in week 58. They spent, $528 on Google prospecting. All right, we want that number, the highest. We want that observation pulled out for every DMA condition and week. So we just proceed that with a group by. Group by. Wow, this is really great typing. Okay, group by DMA condition and week. Pipe that in, and now for every combination of DMA condition and week, it'll give us the highest single GP value and the full observation on that. So now we have 60 rows. So in DMA condition 1, all 3 weeks, Denver was the region within DMA condition 1 that had the highest GP spending. In condition 10, that was Orlando. In condition 11, that was Sacramento, Stockton, Modesto, etc. Okay, question 7. Now we don't just do the report and wash our hands. What I'm trying to get you more doing this semester is, okay, take a look at the data. Is there something we should observe from that? So were there any conditions in which the highest spending DMA changed across the weeks? So if we take a look, so in DMA condition 1, it was Denver all 3 weeks, then it was Orlando all 3 weeks, Sacramento all 3 weeks in 11, Minneapolis, St. Paul in 12, Los Angeles. So if we look through all of these, you will notice that in none of these conditions did the highest advertising region change. Anyways, there will be something to observe in the assignment, but here we notice basically it's the highest population region in every condition always had the highest advertising amount. And that's for good reason. The actual conditions, we manipulated advertising expenditures across regions or across conditions, not within the conditions. So there's good reason for that. One reason I wanted to also do this here is to let you know on the assignment you're not going to have R Markdown. I can't actually have you do the assignment in R Markdown because the autograder does not work with R Markdown. So you have to use just the .r file. What's going to happen is if we take a look at this report, well, one thing I forgot is this was supposed to be saved as high ADMA. So we do that now, it's saved in high ADMA. If you look at high ADMA here in the console window, which you're going to do, it's only going to show you 10 observations. All right, but if you have a report with 60 like we have, or with I think 80 or something on your assignment, how do you, or 120, how do you look at those beyond here? So you need to look at the whole data, but it's not going to show you the whole data. So what you're going to have to do on the assignment is just take a look at 10 rows at a time. So we look at that. Okay, nothing changes there. Move this to 11 to 20. And then go from 21 to 30. Okay, you could try 31 to 50. Will it still abbreviate after 10? Nope, because it'll show you 20 at a time. I don't know what the limit is, after which it won't. It'll just go back to showing you only 20 at a time. But you can take a look and just do that. It's a little tedious, but not that tedious. It didn't take all that long to do that. So you will have to do that on the assignment. Okay, so it turns out, so the answer here would be no. There weren't any conditions that were spending changed. 8, I left blank. There's not a follow-up question I want to ask you here. There is a follow-up question on the assignment. I just left that blank so that our number 9 would align with the number 9 on the assignment. Okay, now we're going to create a report called ToteCond60. So we know we're going to start that way. That's easy. We want it to report the total Facebook retargeting spending within each DMA condition in week 60. So we're total, which means we're going to use a group by summarize, right? Anytime we're adding across the rows, we're going to do that. So we're starting with FEXP week. Okay, we want to know what's happening in week 60, which means we want to isolate week 60. How do we isolate or take out only certain data points in a data frame? That's always filter. So filter, we'll say week double equals 60. Okay, pipe that into. We want the total FR spending within each DMA condition in week 60. So we're going to group by DMA condition. Okay, we don't need to group by week because we've already filtered for week. So there's only one week in there. So if we group by DMA condition, then we do a summarize. And then we say tote FR, call it whatever we want, is going to be the sum of the FR. Okay, that is saved in ToteCond60. Let's take a look at ToteCond60, and now we have 20 observations, 20 different conditions, the total Facebook retargeting spending that happened in that third week of the data set. You can see the numbers are quite variant, despite the populations being pretty similar across condition. That's because that was the experiment, is changing the advertising amounts in week 3. Okay. The reason we did that report, that's a pretty straightforward report. You learned that 2 weeks ago, how to do that. The reason, and this is a stepping stone to help you understand how to use this group by mutate combination. Okay, we're going to create a report called PercDiv. This is a percentage division that shows the percentage of each condition's week 60 spending on FR contributed by each DMA. Okay, so in condition 1, we only had $29 spent on Facebook retargeting, but that was spent across 10 or 11 different regions. So in each region, what percentage, I think we remembered that condition 1 has Denver in it. So what percentage of this $29 did Colorado contribute to it? What percentage was another, the other 9 or 10 regions within DMA condition 1? So in order to do that, what we need is the FR spending in each region, and then next to that, we also need the total FR spending in that condition. And the way we do that is with a group by mutate. So we want to get this total FR spending in every original observation of FEXP week. Okay, and so to get the total, we're going to use basically, we're going to first filter by week 60, because we're still just looking at the week 60 data. Okay, and we're just going to copy this. So it's going to be a group by followed by a mutate. So group by mutate works the same as group by summarize. The only difference, and it's a really big difference, but the only difference is instead of giving you a summary report, it keeps the original data that it was piped into it. So it's going to start with this data here, which is 210 observations. That's 210 rows in that third week. Okay, and then in that week, it's going to add up the total FR spending across the conditions and put that total in each observation. So our final report should be all of this same data here, only we'll have another variable called ToteFR that will give us the total spending in Facebook retargeting in condition 1. So all of these should have the same variable there. So when we do that report, same data, but now it has this ToteFR, and all of the regions in this condition 1 have that 2917 that we observed right here, instead of having one observation of 2917 summarized, it's that value ported into every row. And so now when we say, okay, what percentage of Facebook retargeting spending, what percentage of condition 1's spending came from Anchorage, Alaska? Well, that's going to be 0%. 0 divided by 29.17. What percentage came from Buffalo, New York? We're just going to take $2.50 divided by $29.17, which is probably somewhere around 8%. Right? Well, we need to do that now. So if we want this percentage variable, now we need to do a mutate. We can either pipe this into a new mutate statement or just add another calculation in this mutate statement. If we want the perc FR, the percentage of the FR spending, that is going to be the actual FR variable, the FR observation, divided by this tote FR variable that we just calculated. And so now when we do that, we see 0 as we expected, 8.5%. On this one, half of it was in, I believe this is Denver, the largest region within that condition. Okay, so that is the group by mutate. Again, this is one of the most difficult things. It's actually, group by summarize. We've done tons of those. It's the same as a group by summarize, only instead of giving you the summary report, it adds the variable and it repeats that total calculation across all these observations within that group, and then you can use that to do your percentage calculation. Okay, I forgot this was supposed to be called perc div, so we need to assign that into perc div. So now we have this data frame called perc div. It gives us all that data, including this tote FR and that percentage FR variable. Okay, from perc div, output the highest FR spending DMA from each DMA condition and save it as high perc div. So our high percentage division. So where did we have our highest one? We want the highest one within each region. So we're going to output the highest one. That's clearly going to be, so let's start with perc div. So clearly we're going to want to do a slice max here. And we want the highest perc, what would we call it? Perc FR. We just want the highest one, the single highest one. So we say n equals 1. Only I don't want the highest one overall across all 210 rows. I don't want the single highest percentage region. I want the highest percentage region within each DMA condition, which means I need to group by DMA condition. So I can add group by DMA condition right here, or if I look up here at this report, this is our perc div. Notice we have this groups DMA condition. The grouping is already and is still active within perc div, because if you do a group by mutate, the grouping statement is still active after a group by mutate. So it is still grouped by DMA condition. So when I execute this, oops, I've got a problem here. Perc FR not found. Did I label that incorrectly? Perc out, perc FR is capitalized. Perc FR. Okay. When I do that, and now let's take a look at high perc div. Now we see Denver was the highest in DMA condition 1, Orlando was the highest in 2, and we can see this high perc FR value from each of those conditions. Then it asks, hey, which DMA condition had the highest concentration of FR spending? So that means how much had the highest, which region had the highest single value, or more of its spending or of its FR spending was concentrated in a single region. And then we can just look through here and look for the highest number here in this block of 10. It was 0.66, and that was LA. 0.66% of that condition spending was just in LA. And then, but we have in condition, whatever this is, condition 8, we have New York, New York. So the highest concentration was in condition 8. And I wanted to show you, since we're saving it as a value, you just say high inequality gets, and then we need New York, New York. And this has to be a perfect match, so you might want to just copy that. Actually, hold on. We don't want to put the region name. We want the condition. So we just say high equals 8, and that's all we have to do. Okay, on the assignment, I believe it asks you for the country, which means I would suggest go into the country or the continent or the region, just copy it so you make sure it's a character for character match so the auto grader knows you got the right answer. All right, moving on to question 13. Create a report, and we're going to call this HyperCdiv2. So it should be similar to HyperCdiv. Same as HyperCdiv, but now we want it in all 3 weeks. Okay, so we want the to report the region with the highest percentage FR spending from each DMA condition in each week. So instead of saying, okay, well, let's go back here. We say, all right, in DMA condition 1, Denver had the highest spending, but that was only in week 60. We want that reported in week 58, in week 59, and in week 60. Okay, so I will do this the easy way. Well, actually, I'm not sure that is the easy way. So we know it's going to be hyperc div, sorry, bad typing, hyperc div 2. Okay, that's going to be the same as hyperc div, which means let's start by copying all of this. I want, okay, this was the report we did before. How do we alter this? We want it in all 3 weeks, so we're not going to filter by week 60 anymore. So we're going to group by DMA condition, do all of this. This isn't going to work, but you know what? If you're confused, just do this and see where you're at. What are we missing here? So we have Anchorage. So starting with FEXP week, we group by DMA condition, and then we have perc FR. So we have our percentage FR, unfortunately the scientific notation. And we have it divided by week 58 and week 59 and week 60. And I'm actually kind of confused right now as far as why that's working, because we only group by DMA condition, not by DMA condition in a week. I would expect only one observation per DMA condition. So I need to take a look at FBXP week as to why that that happened. Okay, actually, let's take a look. Yeah, actually, now I think I understand what's happening. So if we take a look at hyperc div 2, notice here we have, if we look at our total FR, this is the total FR spending across DMA condition 1 and across all 3 weeks. Notice we have the same number in week 58 and week 59 and week 60. That's a problem because that's not what we want. What we want is the total condition 1 spending or condition 1 spending in week 58, not across all 3 weeks. So if we want it within DMA condition and week, we have to add DMA condition and week. So if we group by both of those and then execute that, now what we have is the total FR spending in week 58 in condition 1 was 311. So we have 311 repeated those 10 or 11 times across the different regions of week 58. And then the percentage, so it looks like, is this, I think, Anchorage? So in Anchorage, Alaska, 1.9% of the advertising spending was in week 1 was in Anchorage, 1.6%, and then 0 in week 3. So these numbers, this third number, week 59, should line up with our previous report because that was week 60. But now we have that calculation done for all 3 weeks. Okay, so because we added that week, now we have that calculation done in each of those weeks. But then after that, we don't want this report with, 630 rows. We want this report here, this hyperc div, which means we want to pipe this into the slice max statement, right? When we do this, oops, not there. Now, after that, we want to do the slice max. Sorry, I have to pipe this in. After that, we want this report. We want to pull out the highest perc FR in every DMA condition and week. So I would add a group by DMA condition and week, so we pull out the highest region in each DMA condition and week, except we notice that this report is already grouped by DMA condition and week. So when we do that slice max, now it pulls out the highest DMA name or highest region in each DMA condition and in each week. So now we have the percentage FR spending across all 3 weeks in each DMA condition. Okay, so that probably went a little fast. You might not have followed exactly what we were doing, but I hope that gives you some sense of, take it in chunks. Take a step forward. If you have to take a step back, great. That's fine. Just erase and try something new. But that was doing all of these two things, both of these things, doing this perc div report and then getting the highest one, and that was all in one chunk of code. Okay, question 14. Create a line plot showing each condition's highest percentage over time. So this is going to be Q14P. So Q14P, oops, not capitalized. Okay, we're going to do a ggplot. In this case, we don't have to do this code and then pipe that in because we actually saved it as hypercdiv2. So hypercdiv2, that's our data. Then we say our aesthetic statement. So x is going to be week again. Y is we want, I believe we call it percfr again, percfr, capital P. And then since we want this grouped, we're going to use color is DMA condition. And then just our geom line. Oops, sorry, geom line. This is going to give us the same issue because we only have 3 observations on the x-axis. It gets confused as to what grouping we want together. So we have to say group equals DMA condition. And now let's execute this again. So we can see all of our conditions, basically not a ton of dramatic changes happening, just some kind of random changes there. So which condition had the most even dispersion of FR spending? So an even distribution would be the opposite of this, right? Where this is probably New York that had a huge amount just concentrated in that one region. Here at the bottom we have this region, which was under 20%. So the highest spending that was pretty evenly spread across this here. And this is a pink one, and I'm not sure if that's 8 or 9. Actually, we know it's not 8 because 8 was New York, so that's that pink one up there. So this is probably 9. But again, if you're, it's hard to match up colors with across 20 different conditions here. Just do some filtering, and we say, okay, let's take a look at hypercdiv2. And let's just filter and say, all right, where is percfr going to be less than 0.25? Oops. Again, percr is with a capital P. And if we see that's in Cleveland, so that's in Cleveland, Akron. Okay, so DMA condition 9. So that is the one with the most even dispersion. So that's here. Okay, hope that's clear. Now we want to create a report showing the percentage of web sales in each condition contributed by each region, and we're going to aggregate that across all 3 weeks. So we want the percentage of web sales. So now we're not looking at advertising spending, we're looking at the sales. And in each condition, how much of the sales happened, what percentage of the sales was contributed by each region. So we've already done this before. This is basically the same report. I'm just giving you one more chance to practice this. When we're doing a percentage, we need the total web sales in each condition, in each row, which is going to be a group by mutate. So we can actually use FEXP week or FEXP2. I'm actually going to go back to FEXP2. This is the daily data because we're going to aggregate it all anyway. So if we group by, we want DMA condition. So we want the total sales in each condition, and we don't want just the report on the total sales. We want that put in the actual report. So when we do this aggregation, oh, you know what? Now that I'm thinking about it, so this shows you at least that even sometimes I am realizing things are not going to work this way. Actually, I'm going to keep going with this, and I do a group by mutate. This is going to be the wrong thing, and I just realized that, but we'll just show you. I just want to at least show you backtracking and figuring out how to do things. So we're going to do group by mutate, and I want total sales is going to be a sum of web sales. Okay, and that, because it's a group by mutate, not a group by summarize, it's going to put that total in each observation of FEXP2. So when I do that, I can see in condition 1, the total sales was $106,419.83, and that was in DMA condition 19. In DMA condition 8, we had sales of $144,000. And so from there, I want the percentage of web sales in each condition that was contributed by each region. But this report has the daily by each region, and I want the total in each region across all 3 weeks of within each region, and then I want that region aggregated to the condition so I can say the percentage from each region. So what I'm actually going to have to do first is I need to do a group by summarize statement followed by a group by mutate. Okay, so this is not going to work because if I do 368 divided by this 160,000, that's going to give the percentage of the total sales happening in that region on that given day. I want the total, the percentage of this number, 106,000, what percentage of that happened in this region, not in this region on this day. So I need to do some aggregation first. So if I group by DMA condition and then by DMA name, and then I'm actually going to have to do a summarize on that because I want this aggregated first. I want total sales is going to be a sum of my web sales data. Okay, I'm going to delete this for now. Okay, when I do that, let's take a look. Now we have in Anchorage across all 3 weeks, we had $22,000 in sales. Or sorry, 2,200 in sales. In Buffalo was 6,200, 37,000 in Denver, 2,887 in El Paso. What percentage of this total sales in condition 1 occurred in Denver? That's going to be 37,173 divided by the total. Well, how do I get the total next to it so I can do the division? I do a group by mutate. So I'm going to populate this. I'm going to put this into a group by mutate. So I group by, and I want this summed across DMA condition, and then I want a mutate so that it'll give me the total that happened in that condition, but then I want it put into this next to these observations here. So not a group by summarize, but a group by mutate. And then I'm going to say the sum of total sales is going to be a sum of this total sales that we have here. Okay, when I do that, what this should do is keep all this data and then just add this sum total sales next to it. And actually, so we can just see it right next to it. Yeah, I'm going to drag that out. So now we can see the total sales in condition 1 was 76,000. And now I can get the perk sales is going to be total sales divided by the sum total sales variable. And now when I do that, we can see the perk sales. So 48% happened in Denver, 22.9% happened in Anchorage, etc. Okay, one thing I will point out, but you don't have to change this, is this group by DMA condition. I didn't actually have to have this second group by statement because when we ran this up through here, notice it was already grouped by DMA condition. So I didn't actually have to have this group by DMA condition. It doesn't hurt to add it if that makes it easier for you to think about because it's a group by mutate combined. Great, but this still works without that extra group by because this was already grouped. Okay, so sometimes it does require quite a lot of thinking about how do I get, there's multiple steps to get to the report you want. And if you have a really good grasp of what's the layout of the data, that makes it a lot easier. So again, and I hope that was a good illustration of, even me thinking about this, how do I get this report? You take a few steps forward and you realize that's not going to work. I need to do something else first. Okay, in which condition are sales most evenly distributed across the regions? In which condition are sales most evenly distributed across the region? So we can look through all of this and say, okay, basically it's going to be which has the lowest high number here, right? Because if half of your sales are in one region, that's not very evenly distributed. We probably have a sense that it's probably going to be condition 9 because, that was, I believe that's where it was before, where Cincinnati had only, condition Cleveland, not Cincinnati, sorry. Cleveland only had 24.9%. If you want to, feel a little more comfortable figuring that out, we can do another, we can, do, after this, we can go within each DMA condition, we can do a slice max, and we can look at perk sales, n equals 1, and since it's already grouped by DMA condition, if we do that, we can see, okay, we only have 20 regions now. Which one has the highest or the lowest high number? And that lowest high number is condition 9. So that's where we have the highest level of dispersion, the least concentration. Okay, I'm going to delete this because that was, I still want to see the actual full report there. Okay, all right. Okay, now in question 18, we're going to create this data frame FEXP week 2. We're just going to add a variable to FEXP week. We're going to call it Purse Inc. for the percentage of income, percentage increase. So this is going to be the percentage increase in FP spending from 1 week to the next within each DMA. Okay, so let's refresh our memory about FEXP week layout so we can kind of see, all right, we have every region and then we have condition labeled as well. And within every region, how much we're going to be looking at FP spending. So $21, then it goes to $26, then it went back down to $21. We want to look at the percentage increase in FP spending that happened from 1 week to the next. This is our other key tactic that we're learning this week, and that is the lag statement. When we're doing a lag variable, we use mutate, right? It's a new variable. So we're going to say, I'll call it lag. This is FP we want, or FR? FP. Lag of FP. I'll call it lag FP equals a lag of FP. Okay, I always start by just outputting the lag and see what happens, right? We have... so FP spending was $21. That $21.16, when you lag it, goes to the next row. So in this week 2, we can see what the week 1 or week 59, what was the week 58 spending in FP. And then when we go on to week 3, we can see what the week 2 spending is in this lag FP. So when we want to calculate the percentage increase that happened from week 1 to week 2, it increased from 21 to 26. That's a $5 increase. That should be about 23% or something, 25% increase, right? $5 from $20 about dollars. So that should be about a 25% increase. Okay, so how do we calculate that? Now that we have this laid out, that's going to help us. One thing I want to fix, though, is we have this week 3 spending going into week 1 of the next region. We don't want that. So whenever we're using a lag, we want to start with this group by, and then we want DMA name. Okay, so now when we do that, we have our FP spending, we have the lagged variable, and then the week 1, there's nothing to bring into it, so that's just going to be missing. Okay, now that we have this laid out, I'm just going to delete this and I'm going to mutate it the way I want. I want to create this variable Purse Inc. So the percentage increase is going to be, what I want is 26 minus 21.16, right? That's going to be the amount that it increased. So it's going to be FP minus lag of FP. Okay, that's the $5 increase, but then I want the percentage, which means I need to do divided by, what did I increase from? I increased from $21. So the percentage increase is this increase of $5 divided by this 21. So that's divided by the lag of FP. And then because of the parentheses, we need actually the right number of parentheses. If we go here, we can see it's labeled, okay, that's closing off correctly. Okay, so when we do that, now we have this 26% increase from week 1 to week 2. That seems right. And then it decreased from 26 down to 21, so that decreased by 18.7%. Okay, from dropping from $60 down to $40 is a drop of 35%. That seems right. And then notice we have this -1. So it went from $39 down to $0. So that's a 100% decrease. So that's a negative 100% or -1. So it seems to be working. So we got that. Again, so I would recommend whenever you're doing lag statements or percentage increases from one observation to the next, just do the lag, output the lag, take a look at the lag value, and then figure out how to do that calculation. Okay, now we want the mean growth. It shows the mean growth rate in each region. We have our 210 regions here. We have the growth rate from 2 different weeks, and now we just want the mean from each region. And then we want it sorted in descending order of mean growth rate. Okay, so this is actually pretty simple. We just want the mean of these Purse Inc. values in each region. So we start with, well, I guess, this was supposed to be saved as FEXP week 2. So I'll go ahead and do that. And now all we need to do is we're starting with FEXP week 2. Actually, since we know we want this to be saved as mean growth, let's just go ahead and do that. So say this is mean growth. All we want is the mean growth rate. So we're always going to do a summarize statement. So summarize, and we want the mean. So say mean growth. Let me say, I'll just call this mg because the data frame itself is called mean growth. So mg equals mean of, let me refresh my memory what we called this. We called this %. So we want this %, mean of %. Okay, we want this grouped by DMA name, but this is already grouped by DMA name, so we don't need to do a group by summarize here because it's already grouped how we want it. But then we want it in descending order. I hope you haven't forgotten one of our first dplyr verbs we learned was arrange, and we want it descending order, so we're descending by mg. And this isn't going to work. Why? Actually, let's take a look. All NAs. Why? Because the first week in every % region, every observation is an NA. So how do we get rid of those NAs? I'll actually we'll learn, I think next week, we learn a specific technique for getting rid of NAs. But we know all of our NAs are in week 58, so we can just say filter, say week is greater than 58. And when we do that, now when we execute and take a look at our mean growth, we have the mean growth rate. Honolulu had a really high growth rate, so did Juneau. But then we have Cheyenne with this infinite growth rate. So why did Cheyenne, Wyoming report an infinite growth rate? You can probably take a guess, but anytime you're dealing with division, denominators of 0 can be tricky and problematic. So let's just go ahead and find, I wonder how quickly we can find Cheyenne. This might take a while, so maybe it's easier to just go from here. Let's go FEXP week 2, and then just take a look at DMA name equals Cheyenne, Wyoming, Scottsbluff. That's going to be easier to copy than type that out. If we take a look at that data, we notice FP spending was 0 in the first week, and then it increased to 676. That is an infinite increase in spending. And so the average of infinity and 0.427 is infinity. So that's why we have this infinite value. So just a quick maybe warning, anytime you do any calculation with denominators, you got to be careful of zeros. All right, so again, hopefully this was useful, helped sink in, help some of these concepts sink in, give you some tactics for going about using that group by mutate, which can be tricky, as well as the lagged variables, which are tricky. It's not going to be a perfect representation of your assignment. You need to get to understand how that assignment data is laid out and how these commands apply. But I hope that gives you a sense of how to interpret these questions and what you're being asked to do, as well as cement your learning of these concepts. So best of luck.